I'll show you how Vetra sits between the browser, the wallet, and our multi-agent backend to decide if a Solana transaction is safe. We start on an external page, say solana.com. That page has its own CSP and its own JavaScript, so the extension can't just reach and call wallet from the pop-up. To solve that, the extension injects a content script, and the content script asks the background to inject a page-level script. That injected script runs in the background context, so now we can touch window.solana, for example. From there, the flow is: the pop-up sends Vetra Connect wallet, then content forwards, then injected script actually calls connect on the selected provider. We prioritize Phantom, Backpack, and Soulflare because that covers the most common Solana users. The wallet itself still stalks Solana RPC. We test on DevNet. Vetra does not replace the wallet RPC. What we do is sit right before the signature. So when the user hits a DApp and the wallet calls sign transaction, our injected script intercepts and posts a message back on the content script. The content script forwards that to the background service worker. Background is the trusted place, so that's where we normalize the transaction and call our API. At this point, the extension does a post to our backend, sending the transaction data we parse from the Solana instructions, wallet info, timestamp, and user context if available. In parallel, the user can be authenticated through Google. It is optional for the demonstration but important in production because only authenticated users get their analysis stored. User data and transaction analysis go to PostgreSQL. On the backend side, Node, Expert, and Redis is the hub. It receives the analyze call from the extension, forwards to the multi-agent system, waits for the report, caches and queues with Redis if needed, persists to Postgres, and exposes the result back to the extension and to the UI. The multi-agent system is Python, orchestrated with LangGraph, and we use Gemini for reasoning. We always run the three agents: transaction, rug pull, and phishing, because the supervisor alone doesn't have the tools. Each agent returns a score 0 or 1. We aggregate with a noise OR to keep high signals, and we have an override if any agent comes back with more than 0.9 score. The final result is forced to high. The mass also produces a plain language explanation per agent, so the user knows why it was flagged. When the backend sends the final report back, the pop-up, built with React, TypeScript, Tailwind, and Vite, shows extension status, connected wallet, recent intercepted transaction, and a view analysis button. That's the UX choice. Keep it inside the extension pop-up so the user doesn't have to leave the app.